In this module we're going to look at the fundamental principles of hydraulic control, just the basic principles. I like hydraulics because it's nice and simple. There aren't very many, quite easy to understand. Complexity comes, we might get 50 or 100 of the same principle being used throughout a circuit, and that can complicate things a little bit, but the basic principles themselves are quite straightforward. So what we've got here is a spool, hydraulic spool, and we've got some pilot pressure which acts against one end of the spool. We just increase the pressure, the spool moves against the spring because the pilot pressure puts a force on the spool because the area of the spool gives us our force on the spring and moves it. So we've got a supply line to our load, which is a simple gear pump. We're putting in pressure and flow supply here, and we've got a connection to tank on the other end of the spool, which keeps a nice constant pressure. So this is what happens as we increase our pilot pressure. We move our spool and see the pilot pressure is a lot lower than the supply pressure, which could be 100-200 bar. And here's our little formula. Nice and simple. So, principle number 2. What we're doing by moving this spool is we're opening and closing an orifice just here. So we've got a pressure across the orifice. As we open the size, we get variable fixed flow, but we can change the flow rate. So you can see here, we've got the symbol of our orifice, and we've got our flow. And as we move the spool, change the area, we change our flow rate. And we've got our lovely formula. Simple formula for calculating flow. And we know the pressure drop across an orifice. Now, the important thing with hydraulic equipment design is the quality of the spool. It's very difficult to make a spool. Clearances are between the spool and the bore can be around 6 to 10 microns. When you consider the length of a spool, you have to keep the straightness and the roundness, concentricity. It's very, very difficult. Very specialist manufacturing to produce hydraulic equipment, and don't try it at home. So this is the main thing. And the other thing with the spools as well, you get a lot of flow forces here. You want to avoid getting too high temperatures and which breaks the fluid down. So the design around here is critical. The more expensive, better quality valves would have better shaped notches, or directional valves obviously don't have a notch at all. They just go from one side to the other very quickly. So there is no control in a directional valve. What we're looking at here really is a proportional spool. So onto our third principle here. That affects us a lot within hydraulics. We've got a load. We change the pressure on our load. So as our load changes, the pressure changes required at that load, which then changes the pressure drop across our spool. So you'll then see that results in our flow changing. So as we change our load, our flow changes quite significantly. An important and troublesome design thing we have to watch out for, but simple theory. Number 4, leakage. Because we have got a small gap here, there's always going to be some leakage. It always flows from higher pressures to lower pressures, so we'd also get some leakage into the pilot line, which obviously needs to be vented away and controlled. So we can't have trapped volumes because we need to leak these pressures away. So it's a very important design principle and thing we have to be aware of. Efficiency obviously affects efficiencies. You don't want too much leakage, which is why we need the very small, very tight tolerances. But it is an important factor we do need to be aware of for design and maintenance. So, number 5. We've added a seal to reduce our leakage, which is wonderful. We don't get any leakage now. But we do get hysteresis. What you'll see now, the seal just moves around in its little groove, and instead of being lovely and smooth and responsive, we've got a little delay here. We've got extra pressure, so we need extra pilot pressures. Will result in hysteresis. We move one way and move back again. We'll get slightly different values on our settings. We see this quite a lot in hydraulics. So seals, we then tend not to use a dynamic seal unless we have to. Sometimes we do need to, and sometimes it will give us these hysteresis that we don't particularly want. Number 6. Finally, we put a little orifice into this area here, so we've now got a trapped volume. And what that does is, as we change our pilot pressure as normal, we need a certain time for the fluid to flow into or out of this area. So we've added basically a timing element to our circuit. You'll quite often find during commissioning, valves will have little orifices in, and when you build equipment for the first time in manufacturing plants, things aren't quite as you expected in the design. Loads have changed a little bit, so you may need to tweak these orifices. There's often quite a few in a system, but the basic principle is, if you've got trapped in volume now, we've got a time delay in our circuit. So basically, run this little simulation, play around with it, experiment it, make sure you understand these basic principles. They will hold you in good stead for studying and analysing and circuits in the future.